let's look at finding the accumulated value for an investment of $5,000 at a rate of 5% for 8 years. So let's start by looking at how much money would we accumulate for the next 8 years if we compound monthly, and then we'll take a look at how much money we'll accumulate if we compound continuously. So for part C, you have to remember that if you're compounding a certain amount of times a year, then you're talking about the A equals P times 1 plus R over N to the power of NT formula. So we know we're starting with an investment of 5,000, so P is equal to 5,000 at a rate, so we always have to change our rate into decimals, so 5% will become 0.05 as a decimal, and time, T is time in years, so for 8 years. Now the next piece of information we need for part C, it's our N. Our N is the number you compound in a year. So if we're compounding monthly, there's a total of 12 months in a year, so N is equal to 12. Once you can identify all the variables here, all you have to do is plug in. P is 5,000 times 1 plus R is 0.05 over, we're compounding 12 times a year to the power of 12 times A. And for this type of problems, remember you can go ahead and just plug it all in together into your calculator. So you can put all of 5,000 times 1 plus 0.05 divided by 12 to the power of 12 times A. You can put it all at once, and we're talking about money, so money always rounds to 2 decimal places, so we get a total of 7,452 point, and it will round out to 93 cents. If you're talking about compounding continuously, now you're talking about the formula A equals PE to the power of RT, because as you can see, we no longer have N. So all we have to do here is plug in P of 5,000, E to the power of R is 0.05 times T, which is 8 years. So you plug this one in your calculator, and we're going to end up with, we plug in 5,000. You can find E either at your ln or your division. There's 2 ways you can find it. So I'm going to put second ln, so that comes up E to a power 0.05 times 8. We're talking about money, so money rounds 2 decimal places, and that's how we get 7,459 with 12 cents. So, as you can see, if you're talking about the same investment at the same percentage rate for the same amount of years, if you were to compound monthly and you were to compound continuously, as you can see, compounding continuously it's a slightly more money than compounding monthly. Therefore, this will be a better option if you were to pick between both of them.